This week's lesson is on Chapter 2, Ensuring Your Database Structure is Sound. I will cover three main subject areas: columns, tables, and the relationships between the tables. Let's begin with columns, essentially fine-tuning columns by following common best practice tips on naming columns and structuring columns. Tips on naming columns. The names of your columns should be descriptive and meaningful to your entire organization. Keep the end user in mind. The name should also be clear and unambiguous. By that I mean you can only use a column name once. There should not be two columns with the same name, even if those two columns are in two different tables. Do not use an acronym or an abbreviation for a column name unless it is standard and well understood. Otherwise, use the actual subject name. Finally, the column name should be singular because it is representing one subject. Design tips on structuring columns. A column should only identify one characteristic of a subject. The subject is represented by the table. If a column represents more than one characteristic, that column should be removed or split into multiple columns, one column per characteristic. A column should contain a single value only. A column should not store the result of a calculation or a concatenation, which is an example of a function. It should not store calculations and functions. This is an example of a table containing columns that have more than one value. If you take a look at customer name, this could be split into last name, first name. And if you look at street address, this can be split into the street, the actual street name, the city, the state, and the zip code. You are looking at an example of a table that has two columns with multi-part components. The solution, as I mentioned, would be to split customer address out into 4 columns. The same could be done for first name and last name. Remember, a column must have a single value. Either remove the column or add more columns, one for each characteristic, one for each value. This is another example of a column consisting of more than one value or more than one characteristic. In this table, we have the column Instrument ID. It looks like there's just one value in the column, but if you look at the naming convention of the column, we can see that it is a concatenation of category and ID. Therefore, we would want to split this out. Here we have an example of a table that contains a column with multiple values. If you look at the certificate column, you will see in the first row 4 certificate IDs, and the second row 3 certificate IDs. So this is not a multi-part column. This is a multi-valued column. We would want to split this out. To split the certification column, we would create a linked table. The table name in this example is Pilot Certifications. It has the pilot ID from the pilots table, and it has the certification ID. One certification ID per row. This allows us to also create another table just on certifications. The certification ID is the key for the certification table. The pilot ID is the key for the pilot table. We have a linked table that contains only the pilot ID and the certification ID. Each row is unique. We just reviewed fine-tuning columns, which are the structure, the basic structure of a table. Table consists of columns and rows, the rows being the values for those columns. Now let's take a look at fine-tuning tables. When designing a table, keep in mind that it represents a single subject. It must have a primary key column to uniquely identify each row in the table, and it cannot contain duplicate columns. This is an example of an improper design because it consists of duplicate tables. If we look at the staff table, we will see we have a primary key called staff ID that uniquely identifies each row in the staff table. On the classes table, we also have staff ID. This allows us to join classes to staff. You will also notice in the staff table, you have the staff first name and the staff last name. So why is the staff last name and the staff first name in the classes table? This is an example of duplicate columns. We do not want the last name and first name in the class table. The staff ID is sufficient because it allows us to join to the staff table and retrieve the staff first name and last name from that table. This is the solution, which is to only have the staff ID in the classes table. No duplicate columns on last name and first name. Here we have another example of improper design due to duplicate columns. In this one table, we have Committee 1, Committee 2, Committee 3. We do not need a column for each committee in the employees table. What if we had 10 committees or 20 committees? This could become an issue very quickly. The solution is to create a linked table. In our example, the linked table is committee member. It consists of employee ID, which comes from the employee table, and it consists of committee ID. We can also create a committees table that has a key committee ID. This allows us to join committees to committee members, from committee members back to employees. And now we do not have multiple columns for every instance of a committee in the employees table. Here is another example of duplicate columns within a table. We have employee home phone, employee work phone, and employee cell phone. This is very similar to the previous example where we had Committee 1, Committee 2, and Committee 3. The solution is to create a phone numbers table, include the employee ID as a foreign key in the phone numbers table, include a phone ID that uniquely identifies each phone number. Now that we've reviewed a few tips on naming and structuring columns, let's go a little deeper and talk about a particular type of column which I've hinted to in the previous slides, which is the primary key column and the foreign key column. Now let's review some design tips on structuring key columns. A key column uniquely identifies each row in its table. It can consist of one column or a combination of columns to form a unique value. It cannot contain unknown values. It cannot be an optional column. A value has to be entered in the column, and the value has to be unique. It cannot be unknown. It has to be a valid value. And this value should never be modified once entered into the table. Let's look at this example of the pilot table. we have a pilot ID that uniquely identifies each row in the pilot table. This is an example of an improperly designed table. Why is the design incorrect? Because there is no key column. There is no column that uniquely identifies every single row in this table. The solution would be to add an employee ID column to the table to uniquely identify each row in the table. Now let's move from columns in a table structure, to relationships between and among tables. This is an example of a one-to-one relationship between two tables. This line indicates that for every one employee, there is one employee confidential record. This tick here on the line indicates 1. We also have the relationship in the reverse direction. One record in employee confidential is related to only one record in the employees table. Again, this vertical line, this vertical tick mark indicates 1. This is an example of a one-to-many relationship between two tables. The single line, the tick mark, indicates that a single row in the instruments table is related to only one row in the students table. The tick mark is on the line next to the students table. Again, this line indicates that a single row in the instruments table is related to only one row in the students table. So I'm reading from right to left. It was easier before when there was a single tick mark on each side, but now it's very important that we know how to read the relationship when we have more than just a tick mark, but also in this case, we have the crow's foot, which is indicated here on this side of the instruments table. The crow's foot indicates that for a single row in the students table, there can be many instruments in the instruments table. The crow's foot indicates many on the instruments table. The tick mark, vertical tick mark here, indicates one row in the students table. In our last lesson, we discussed linked tables. Here we see a good example of the value of linked tables, because without this linked table, there would be a many-to-many between pilots and certifications, which we discussed in the last lesson. We do not want a many-to-many between two tables. Therefore, we create a linked table, and now we have a one-to-many from pilots to pilot certifications, and we have a one-to-many from certifications to pilot certifications. The unique relationship is in the linked table for pilots and their certifications. Once we've created our tables and established relationships among our tables and entered data into these tables, what happens if we want to delete data from one table that's related to another table? In this example, we have the committees table and we have the committee members table. We have a one-to-many relationship. A committee can consist of many committee members. But what if we want to delete a committee? We would have to define deletion rules. We don't want to delete a committee and the committee members are still in the committee's table, but there's no committee. There are two types of deletion rules. One is to just restrict the deletion and not allow a committee to be deleted if it has committee members. The other rule is called cascade deletion, which means if you do delete the committee, automatically the committee members are deleted. You will see the letter C near the relationship on the line between committees and committee members. The C indicates cascade delete. If you delete a committee, the committee members automatically will be deleted by the system. I will now explain the participation types that are available to define the participation of one table with another table through its relationship with the table. A mandatory participation type requires that a row exist in the other table. An optional participation type does not require a row in the other table, the subordinate table. If we look at this example, the second line, the second tick mark here indicates mandatory. If we look at the circle here, it indicates optional. We cannot have department employees if there's no department. Therefore, the tick mark is on the relationship line next to departments. A department must exist if you're going to assign employees to the department. So keep in mind this first tick mark means one record, a one-to-one relationship or a one-to-many relationship. For the examples, the second tick mark indicates mandatory or required. The circle indicates optional. I have covered relationship types, and I have covered relationship participation type, and now I'm going to cover relationship participation degree. It usually is indicated by a numeric value. In this example here, we have 1, 1, and in this example here with entertainers, we have 0, 6. What does that mean? An entertainer can be associated with one and only one agent. It's one on both sides. But although an agent doesn't have to be associated with an entertainer at all, indicated by the 0, an agent does not have to have an entertainer. If it does have an entertainer, it can have multiple up to 6. An agent cannot have any entertainers, or an agent can have 1 through 6 entertainers. An entertainer, though, is only associated with one agent. Finally, on this same relationship between agents and entertainers, what does the R represent? It represents a restricted deletion. You cannot delete an agent if the agent is associated with entertainers. Essentially, you do not want a row to be gone from this table, but over here in the entertainers table, you have entertainers associated with the agent that is no longer really an agent because he or she is not in this table. That is why the R is here, to restrict a deletion. If the agent has 0 entertainers, then an agent can be deleted from this table. But if an agent has at least 1 entertainer, the agent cannot be deleted from this table. How would this be resolved? The entertainer would have to be deleted before the agent could be deleted. In closing, we have covered columns, naming tips, structure tips, tables, and the relationship between and among tables. This week's assignment is just a quiz on Chapter 2. Next week, the next lesson, Chapter 3, you will have another quiz, and after that, starting with Lesson 4, we will begin SQL code.